How's it going, Lone Riders? What you just saw then was the crash test that we did in Annecy, France last year, and we hammered these crash bars all day. That's just a couple of snippets. We will produce other videos and show you guys down the line, specifically on Monday, because that's the pre-sale for these crash bars. But today I want to talk about how we built them and the concept and the ideas behind them, and why I think they are the most superior crash bars on the market that you can possibly get today. So yeah, I'm Andrew. I'm the product guy at Lone Rider, and I develop all the products and manufacture them all. What these videos are for is just to explain to you guys and show you guys what we do here behind the scenes, and also get your feedback, take that feedback and integrate it back into the product. So if you go down to the comments and leave us a comment about, if you see something that we could improve, or some ideas that you had, or experience that you have, some new ideas, let us know, and we will get into it. Most of you guys have been following me for years and years, so you'll probably notice that I haven't been available the last couple of months. Pretty busy here at Lone Rider HQ. We've been developing a lot of products, and I'll quickly cover them just to cover them, and then we'll jump into the crash bar development process. So coming this summer is the Moto panniers. So these are awesome. These are super high quality Moto panniers, and they get side boxes, and they complement the top case that we've developed last year as well. It looks primo. We're already in production. So we're already in production. I'm in the factory often to check them and make sure that everything's going all right. But those will be coming this summer. So this is actually... So that's a golden sample of the Moto panniers, and a golden sample is basically the final product that we sign off on to say, okay, make 1,000 of them, or 2,000 or 10,000 of them. So essentially we've all signed off on it and saying this is exactly what we want. We're all on agreement for every little detail, and that's the golden sample right there. That'll be coming soon. More info coming in the next... I'll make a completely new video about it. It deserves its own video. Next one is ADV bags. So these are Rackless luggage bags. You might have seen a few videos on these. Kevin, he's been thrashing them. He's been testing them. We've been testing these really hard. We want a primo superior product. So we've just got all the pro riders to test them and hammer them and give us all the feedback. And we've integrated all that, and now we are also in production, and they'll be coming mid-June, so next month. So those are golden samples. Those are the ones we're shipping out, and they are coming very shortly. So we're signing off. The QC are onto it. They're in production right now, and the materials are all tested, and we're really good to go here. So keep an eye out on those emails coming out soon. So if you want to catch up, if you want to stay in the loop with us, I'll leave a link in the description down below, and there you can sign up to the email, and that's when we will send out the information basically. So if you like that kind of stuff, hit subscribe, and while you're down there, hit the like button. I really appreciate it. If you see something that we could update, change, ideas, let us know down in the comments down below. The next one we've been working on a lot is the motorcycle lights. People love them. We're getting really positive feedback about this. So we're going to expand the range out because we've got a stable product. We're going to extend it. But we're going to do something a little bit different. We always do something a bit different here at Lone Rider. So this time we're going to do something a little bit different again. And watch out for the space because it's new and it's unique and novel. So what we're trying to do is give the riders the best possible experience ever, and not shoot for the normal goals that people normally associate with lighting. So keep an eye out for that too. So let's just get into the crash bars, because on Monday that's going on pre-sale. They're already on the boat. They're all already shipped. So they're in the container, and they are arriving at all the third-party logistics around the world, and they'll be ready to ship very shortly. So they're going into pre-sale next Monday, the 19th of May. Alex, the marketing guru here, will explain more in his videos, but I just want to jump into the technical side right now. So if you know Lone Rider, you'll know that we actually do things a little bit differently here. We take what we know from our personal industry knowledge, because we all ride. We've been riding for years. We're avid riders, and we put this into our products. But we also get feedback from you guys. So if you look down the comment below, there's probably guys down there telling us about their experience with metal. Maybe he's a welder, he knows something about welding, how we could do that better. And then we have material experts, and we have riders that have experience with broken things on the road. So all that feedback we take, we collect, and we throw it into our products. And this is the result of it, this crash bar. And as a result, it's the most superior crash bar system in the world today, in my opinion. What do we do differently here? So normally crash bars are designed to just be rigid, okay? They're rigid and they're hard, and that's it. There's a big solid shell around it. What we've done a little bit differently here, and what we've been thinking, is we don't want that system. We want our system to bend and absorb that impact. To absorb that impact, so our product is the one that is taking the beating and not the thing that it's supposed to protect, which is the bike. So all the parts designed, everything's designed for one main reason. That is to absorb energy. And we've done that a few ways. We've done that with the metal, so it flexes. So the metal flexes in a way. So we've weakened parts and strengthened parts and changed it around so we can really control what bends and what flexes. And we've also added in some cushioning systems. And that's done by PA66, like a slider system, and rubber. A type of rubber. And what that does is absorb the energy as much as possible, so that energy is absorbed on the crash bars and not pushed through into the bike. And when it's pushed through to the bike, what happens is the bike can be damaged from that, right? You can bend out the chassis, you can damage and like twist out the subframe, and that's what we want to avoid. We want to replace the crash bars and replace the crash bars, because that's the cheapest and fastest and easiest way. You don't want to go in there and start realigning your bike, right? That's very expensive. You've got to do a whole tear down, you've got to realign with lasers and special machines, and then you've got to do a whole rebuild. It's just easier to change out the crash bars. We're not saying we're going to make this thing not flex or move. It's designed to do that, and that's the energy that we're absorbing, and that's a good thing. You could see a few things here. We've got on the crash bars on the right hand side. Okay, let's start with the skid plate. Go bottom up. Skid plate. We've got rubber inserts under the sump, and that absorbs the energy. So there's a distance. There's nothing screwing into the sump for a start. They're screwing in from the sides of the bike. So the skid plate is kind of like hanging there, and we've designed in these not break points but weaker points. So what we're going to do is, when you do go over the limit, elasticity limit, basically, what we'll do, these parts will bend and they can be replaced, but of course not bend enough so to damage the bike, right? But they are designed to crush and crumble. And then what we've also done underneath that is put rubber under everything. So the connection between the metal protection parts and the bike has got a layer of padding around it. It just gives a lot more protection for the bike. So moving up to the lower crash bars, we've got a slider system here, and it's actually replaceable. We can replace it, and this is PA66. So this is quite like a type of nylon. This is quite a strong plastic. What it does is slide. We're creating less friction. That friction is passed onto the slider, not onto the bike. And also behind that is a sandwich of a type of rubber as well. So that absorbs it. And if you can't do it by hand. If you push it, nothing will happen. But when you put the whole weight of the bike on, you'll see that the whole part compresses, and it's a floating system. So it's not actually connected to the crash bar in a traditional sense. It's not bolted on there. It's bolted around it. So what happens is that sandwich will compress, and then that'll absorb the energy and not go through your bike. This doesn't actually attach to the bike. Why? Is because we want it to flex. We want that flex in there. So you can put a bolt through there, right, and connect it, and it's all rigid, but we don't want that. This is the wrong angle for protection, because we want the crash bars to be the one that absorbs the energy, and we also want the crash bars to be the ones to be replaced, because that's way cheaper and way more practical than replacing like a subframe for a motorcycle costing tens of thousands of dollars. We've designed it in a concept where at a certain point the metal will not come back into its place. It will not. So I made a few videos before I lost the audio, so I've lost lots of videos here. So I've destroyed all my samples. But basically what we're doing with our metal is we're pushing it. We've pushed it by testing it. We've figured it out by testing it and run simulations. Essentially, we've got springs from the side of pen here. At one point, it'll bend, right? And it'll come back into place every time, right? That's the way the spring works. At one point, if you bend it too far, it won't go back. It will never go back into its position. So at that point, we've figured out where those points are, and we've designed around those points. This is what this design does. In most common cases, and most normal cases, and actually streamer cases, because we took it off road for days and days and days and we smashed it to bits, and it was fine. But what happened is we've pushed this limit to keep it inside this elasticity point region, and then anything apart from that will also protect, but will just need to be replaced, the bars, because that's what we want to do. If you've passed that point where it's really bent out of shape, it's done its job. If it passes there and doesn't come back, then it's worked, because what happened is it's taken the energy. That is the concept. Okay, hopefully you understand it. If not, let me know in the comments down below, and we can have a discussion, because I think it's really good, interesting discussion to have as well. So the second thing I want to talk about is the design. So we've got function down, and we've tested it. It works primo. Now we want to talk about design. So that's the second thing. It's got to look good. It's got to look good and work well too. So I think we've nailed it as well. We've made it fit the bike, like pretty well. It's kind of a special bike too. And we're talking three-dimensional shapes here. We're designing pipes in three-dimensional shapes and stuff like that. So it's not that easy because A, it has to function super and it also has to look good. So this is Alex riding his bike, looking pretty badass, I must admit. And you see under the cylinder there, the amount of protection that it's got. It's completely covered. So this was the first prototype, or second prototype that we produced, and you can see there it just didn't look good. It just didn't look proper. So we design it on CAD, we produce it, we put it on the bike, and then we see, okay, this doesn't look that great, because there's so many variants going on here, so many things at play, right? So that's why this was our first design here. So just to say we've gone through several iterations just on the design front. This is the system on the GS and the GSA, BMW R1300 GS it works, and for the BMW R1300 GS Adventure. So here's the deal with this. The skid plate works on both GS and GSA. The lower crash bar works on both GS and GSA. The upper crash bars only works on the GS. If you have a BMW crash bar, that OEM, then the skid plate will work. With our Lone Rider skid plate will work with the OEM BMW lower crash bars. The upper crash bars from Lone Rider will also work with the OEM BMW lower crash bars. So it's all interchangeable, basically. So we want it to work with the OEM stuff because the guys have put money into it. We don't want to, we want it all to work together so it's all nice. And so that looks good on both bikes, looks primo. Upper crash bar for the GSA, I'm not sure. If you've dismantled the GSA before, it's quite a big mission. And I'm not sure if people are into it. They'd probably have to go to a dealership to install them. And they have to basically take the whole tank out and all that stuff. So we're going to not pursue that right now, but tell me what you think down in the comments below of the design. So this is on the GS, the crash bars on the GS. And what you'll notice on the cylinder head, what we're trying to protect here, there is the slider, so that protects the whole face of it. And then underneath, we've got this bar that sits there, and that also protects the dirt and the stones that come from underneath. And on the front, you notice these two bended sheet metal parts. What it does is shovel the dirt out. So it keeps the dirt out of the cylinder and between the cylinder and the crash bars. And that's really important because what happens is we don't want dirt in there, because what happens is it scratches the cylinder head, and then if a stone gets caught in between and then there's an impact, then that can break the cylinder head and all that kind of stuff. So that's what that's in there for. The skid plate as well. It's a full length skid plate. And it is a solid sheet. Okay, one of my riders called me last night and said, why didn't you put a hole in the skid plate for the oil? And the reason is because when you do that, the oil goes everywhere most of the time. Unless you've got a down pack system or a special little toolkit that siphons out the oil, generally it's better to take the skid plate off and take the oil out to do an oil change. And the reason for that is a fewfold, but A, it reduces mess, because when you undo the sump plug, it goes everywhere anyway. And also, it gives you a chance to clean under there and inspect underneath to make sure there's no cracks and all that kind of good stuff. You can do a proper service on it. That's what a service is for. So that's why there's no hole in the bottom to do the service, to remove the cap. And that's for a good reason as well. If you want to drill one in there, by all means, drill one in there. That's no problem. You can drill straight through it. Also, we tested it. That's the GSA with the lower crash bars and the skid plate. So my computer's struggling at the moment with so much data, so I can't show you 3D live CAD, but this is how we built it. So essentially, we scanned the GS 1300 with the R1300 GS, scanned all different parts. So all those different colors are different scans. So we got to scan, take off the fairing, scan, take off that part, scan. So we're doing multi-layers. So we can basically rebuild the bike and then get in under all the connection points and stuff. And then we design it in 3D. So it's essentially in 3D space as well. So if we move one point, then everything else moves as well. So it's all interconnected. It's quite a nice system. Quite a bit of work to get this down and to get the scan. The biggest work up front is the scanning. This takes huge amounts of work, and the computer resources that we need is huge as well. You need really strong machines for this. And the scanning material now, the scanning devices are actually getting really cheap now. You can pick one up for $500. You can pick one up that does the job good enough, but we are using ones that is much more accurate. But the data volume that they produce is huge. So you do need, you can buy a cheap scanner or a scanner, but you need the backup of the PC as well to process the data. So that's how we built it. We built it with SolidWorks, and we built it in a 3D sketch form so we can change the design as we go and like really optimize the design. What you'll notice down the bottom too is quite a thick skid plate, and the reason for that is because we tested a HDPE skid plate, or a certain type of HDPE, high density polyurethane, and this, we didn't go with this because of the melt. It melted a few times when I tested. We tested, and also we had a few impacts, and then the plates were like stuck on the bottom of the sump and melted as well. So we're not quite there yet, but we like the idea because it absorbs the energy, right? That's the concept that we run with. So that's looked at this kind of technology. Why we went with it, because it absorbs, like this polymer absorbs the energy. But we couldn't refine it just yet. We're still working on it. It's possible, but it's all about timing and cost and stuff. So we just went with the traditional aluminium because we know it works and it works well, and we can make it super, super strong. So that was just a side note there. We do try many different options. It's from the back, you can see, the front, and the top as well. The top's also important. The cylinders are not actually parallel. They're a bit offset. And so all the bars, so they're not actually equal. So you can't just mirror this. You have to make two different designs on each side. So it's all replaceable as well. So we want it to be replaceable because when it damaged, we want it to bend and flex, and that energy stays in the crash bars or gets dispersed in the crash bars and not on the bike. So we want to save the bike. So yeah, we can replace the skid sliders, we can replace bars if necessary, or the bolts, because they do bend as well. The bolts will bend as well. So we got to replace all that stuff as well. But generally, we'll give you a really good rundown on how to install them. You can install them by yourself at home as well. So they're not like super complicated, and a few tools will supply everything you need. Just use Loctite, guys. Use blue Loctite for this. We don't want things to rattle out on the road. And also check them occasionally, right? You want to check stuff. The vibration on a bike is huge. So that's it, guys. That's the video about our crash bars, new crash bars for the 1300 GS and GSA. And these are super high quality. The feedback we've got so far from the testers and stuff, they're impressed. And it makes me proud because it took a lot of work to get to this stage. And we are very, very happy with the result. And now they're on the ship. They're literally on the ship sailing right now. They'll be hitting the 3PLs, the third-party logistics centers, very shortly. And from there, we send them out to you. So keep tuned for that. On Monday, the 19th of May, 2025, they go into pre-sale. So we don't do sales often, just pre-sales and Black Friday. And so there's only one chance to get this, or two chances to get this this year, and one chance next year, end of next season. So yeah, now's a good time to do it. If you like these kind of videos, if you want to give us feedback and all that kind of stuff, do leave us a comment, subscribe while you're down there, and hit that like button, all that good stuff. And I'll catch you very, very shortly. I love doing these videos. I miss doing these videos. And so I'll catch you soon.